All right, let's get started. Hey everyone, I'm Ty, and at Twitter in 2013 we started a project to bring all of our mobile SDKs under one umbrella to offer to our external developers. We call this project Fabric, and today I'll be giving you tips and tricks for building your own SDKs libraries or tips that you can apply to making your apps more performant from the lessons we learned while building this. So what exactly is Fabric? It's a set of modular SDKs that we built that share a common platform, and that allows us to reduce the footprint and use a consistent approach to building out and solving these problems. We released it last fall, and it's completely free for everything we offer. We believe it's a great way to bootstrap your mobile apps. As we were building it, we kept several goals in mind, and they helped guide us in making API decisions, and we think these can easily be incorporated into your own projects, and I hope you'll be able to take some great things away from this. Get a little closer. Is that better? Perfect. We currently offer 7 SDKs that are grouped under Fabric. These are initialized and maintained by our base AAR. It's the platform. And most of these can be one or more Java artifacts, and we use AARs for these today, but they can be any specific artifact. The Crashlytics team had a huge influence on the way that we built these. So many of these SDKs encompass the existing tools that were built by the Crashlytics team and have evolved since. The SDK functionality that we launched with includes crash reporting, analytics, beta distribution, Twitter single sign-on, embedded tweets, sign-in with phone number, and our advertising exchange. But it's much more than a set of SDKs. It also deeply integrates into the developer workflow. We offer IDE plugins for all major IDEs for iOS and Android, and build tool integrations for Ant, Maven, and Gradle, so you can quickly onboard new applications, inject the code that's needed to use them, provision your app keys, and then provide dashboard functionality to access the data. Part of our platform is providing this consistent backend experience. We offer dashboards for all our products, so you can monitor and interact directly with the SDK functionality. An example here is using our Answers SDK to observe stability over time in an app. To help developers get started with Fabric, we created an open sourced game we call Cannonball. It's a social magnetic poetry game that you can get on the Play Store today. Check it out to see Fabric in action. Now that you have an idea of what we've been building for you, let's talk about how you can take the learnings from Fabric and apply them to your own SDKs or libraries. But before we hop into code, let's think about some considerations that we should probably make if we're going to be building a new library. The first consideration is you need to figure out what need are you actually serving. Is this for internal developers to use? Is it for public developers? Who's going to be using this? What's the value that you're adding? Is this already a really saturated space that you're working within? Why not use something that already exists? Then you need to figure out the format that you want to deliver your artifact in. On Android, there's 4 major types that you can choose from. Library project is the oldest. It's kind of just standard code that you check out and link your project against. It's generally the most flexible, but it has the least number of guarantees. What if the consumer forks it? How do they stay up to date on changes? Jars are a great option, but they don't include a way to include Android resource files. This rules them out for any Vue-related library. The APK-lib was introduced as a community-focused approach of zipping up a library project and delivering that via Maven. It's not widely supported. I wouldn't recommend it. It's not the sanctioned way of doing things now. AARs are the current sanctioned approach by Google. They are zip container, including all the resources and the compiled source code. The downside is Eclipse isn't officially supported yet, and there are still many developers using Eclipse today. The Fabric team, we chose to use AARs, and then in our IDE plugin for Eclipse, we actually use Ivy to resolve that against our Maven repository, and then we unzip that locally and inject that as a library project into your workspace. So that gets around the problem for us. If you have your own thoughts on that, you should probably think about if you want Eclipse as your users or not. Then you need to consider if you want to do an open source or a closed source library. It's a big question. Open source gives you a lot better adoption from the community. It gives you more excited engineers internally to work on it. You get much more stable software from external contributors. But is this solely an engineer-focused library, or is it a full product? Do you have a backend service that you need to interact with? Sometimes it's a decision outside of your team. And on Fabric, we have some of our libraries as open source and some as closed source. Also consider your licensing when you're doing this. GPL licenses can be dangerous and force consumers of it to also have to GPL license their code that way. I'd recommend you something more flexible, like the MIT license or Apache 2. The last consideration you need to make is where you want to host your artifacts. Maven Central and JSON are great options. They're standard repos that are referenced out of the normal build tools, but they require you to have an open source library so that it's safe for their users to consume without having terms of service that the user may otherwise implicitly have to agree to. If you have a closed source repo, then you need to use a closed source library. Then you need to implement your own custom store and then instruct the developer on adding that to their build script. Okay, so you figured out your product strategy for your SDK. Let's talk about two qualities that we focus on heavily for Fabric. The first goal that we came up with was building an SDK that was powerful. And some things that means to us are ease of integrating an SDK, the extensibility of the API, handling failure gracefully, and the use of runtime detection for flexibility. When anyone sets out to build anything, whether it's for their own consumption or for other developers, they don't try to make it difficult to use. They don't mean to have 10 pages of documentation or a constructor that has 15 parameters on purpose. But it happens. It makes using SDKs, open source libraries, or even parts of your own code much more difficult to use. So the first thing that we wanted to do with Fabric was make it very easy to use. We wanted to create the easiest way possible for developers to get up and running, and it doesn't get a lot easier than this single line. You just put this in your application on create or your activity on create and you're good to go. But with Fabric, we require an API key so that we can provision it against the backend and we can authenticate the device that's talking with it. And so we use our plugin to inject that into your manifest. But we also support providing this through other options if you have an open source library as well. For example, you can include it in a property file. Then in our initialization, we use the package manager and the application info to parse that from the manifest and talk to our backend with that authenticated API key. This is another example of getting dependencies when they're needed. When the developer passes a session into our Twitter API client, we use that. And if they don't pass an already authenticated session, then we'll use the session manager, which stores the active session, so that we can still authenticate the requests for the user. Hopefully some of you are thinking, hey, why not use a dependency injection framework like Dagger? That's a great suggestion for an app. However, the second quality we're going to talk about in a bit is being lightweight, and oftentimes using third-party libraries like that add a lot of weight to your application. Another thing that's really important to us are that our SDKs are very modular and extensible, because developers have unique needs and we want to provide building blocks for them. We've introduced this concept of modular SDKs, or a separate product, a functional unit, so the developers can only add the pieces they're looking for their app from Fabric without including unnecessary code in their app. And they can easily update their app in the future with new libraries that we put out. Existing Crashlytics users may be familiar with this. Additionally, we had some overloaded constructors for additional parameters. You could set a listener that notifies your app when it crashes. These are all super useful things, but you can tell they were added over time and in different styles. And aside from being inconsistent, the intention with some of these calls isn't even very clear. Unless you read the Java docs, you wouldn't know which order you need to call these. The reality is you were supposed to call these before you initialized Fabric. And that's just confusing the users. So why don't we try to make this better? If we need these parameters before start is called, why don't we just add them to the start call? And then we add more functionality to Crashlytics. We'll just keep tacking on parameters. Everyone loves passing around a series of nulls or meaningless lints. No, I think there's got to be a better way. So what did we do? We decided to use the builder pattern, where you can specify additional optional parameters for each SDK. The pattern alleviates the burden of having these methods with constructors with so many inputs, and it ensures that the SDKs are initialized and that they're in an immutable state, so they're thread safe when Fabric is initialized. We also made use of the builder pattern in Fabric itself, not just Crashlytics, allowing developers to build Fabric with optional parameters. This is how you turn on logging, for example, or provide a custom logger so that it can interact with your own framework. Part of making extensible code is allowing the developers to choose to be notified when certain behavior happens. Here's an example of initialized Fabric with the builder pattern. We set an initialization callback that notifies the user once all synchronous and asynchronous setup is done, or if there were any issues. Developers have quite a range of tools, therefore they need a lot of flexibility in their code. I mentioned earlier that we have a custom logger interface, and we provide this so that if you're using something like Timber, or you don't want to use Logcat, you can override this and set it on Fabric, and then we'll respect your logging choices. But if the developer chooses not to implement that logging interface, we provide a sane default that takes advantage of the standard Android logger. Here's another great example from Fabric. Our Twitter kit provides an easy-to-use Twitter API client so that some popular Twitter endpoints are defined for you already. Our client uses the persisted session to automatically sign your requests. What happens if you want to hit a more obscure Twitter endpoint that we're not currently providing through the SDK? You don't want to re-implement all of our authenticated client and have to sign your own requests. Instead, you can extend our Twitter API client and provide your own retrofit style annotation, and we'll handle it for you. More than just Java code, though, a good library has views that can allow style properties to be overridden as well. This example is taken from our tweet view from the Twitter UI SDK. The developer can customize various colors used in rendering the tweet, but an important thing to note is that DEX merging doesn't namespace for libraries. So if you don't namespace the attributes yourself, it's quite easy to conflict with a user-specified style unintentionally. Don't set a generic name like background color, and usually prefix it with your library name or something else that'll be uniquely identifiable. Aside from the implementation details we just talked about, when designing our APIs, we generally like to think about a few traits. The first is being intuitive. An API should act the way the developer expects without having to reference documentation. And it should have a consistent API. Name your methods in a similar way and provide a similar design pattern. Use common language. Don't name the success method in your network callback success and the success method in your database operation on success. An API should be easy to use and hard to misuse. Validate your inputs. Have sane defaults when dependencies aren't provided. Make the developer of your SDK feel safe, and give them an understanding of what's going on under the hood. Developers are impatient and inquisitive, and the faster something fails, the better. If you've been using Gradle, you'll know what I mean after it fails after 5 minutes of build resolving. So you should throw expected exceptions so the developer can know if there's a problem very quickly. In this case, the developer tries to set a null logger on our builder, and we throw an exception so that they can quickly recognize their mistake and resolve it. But your SDK shouldn't fail in production. Preserving the trust of your developer is the only way to keep code in their app. Their app is often their livelihood, and they won't bat an eye at replacing a crashing library. So you can provide the developers extra info when they're working in debug mode by failing fast with a clear exception, but concealing potential problems in production and allowing the rest of the app to continue running. Maybe it's not the worst thing in the world that their app doesn't crash and they don't get crash reporting. That's significantly better than your crash reporting library crashing their app on launch. Your SDK doesn't usually have the same luxuries as an application. You don't get to pick customers. As an SDK developer, you need to provide maximum flexibility so that the developer never has to make trade-offs when deciding on your library versus a competitor. Have you ever checked out an app in Google Play and thought to yourself, why does this flashlight app need to modify or delete the contents of my USB storage? With M, the permissions are changing a bit, and it's going to be a lot more flexible, but as an SDK developer, you don't have the luxuries of knowing if the app developer is yet targeting that. So there's going to be some interesting thoughts to be made on how we detect the permissions or we prompt for permissions. There's the dangerous permission set that are privacy-conscious ones, and then there's the non-dangerous group, for example, access network state, which we'll get into. With the current model before M, if you add in a new permission after the app has been launched, it'll actually prevent the user from auto-updating. So if your library in your AAR declares a new permission, the app developer oftentimes won't notice that that's being introduced until they upload that to Google Play, and it warns them. If they happen to miss that, it's just going to break auto-update from their users. We've seen that affect the long-tail update quite significantly. For Fabric, we just require the internet permission, and with M, that won't even be a concern anymore, I think, since it's considered a non-dangerous permission. We then provide hooks so that users can set additional email that they acquire other ways. For example, if we wanted to take the user's email, we have to require something scary like get accounts. With M, we would have to prompt the user for this permission, and they might be concerned since the feature's set into them. Instead, our SDK allows developers to gather this information on their own, and if they choose to set it on Crashlytics so that they can investigate a crash, that's their business. But in order for the SDK to be robust, it should take advantage of these features when they're available. This is where runtime permission checking comes in handy. An example is checking the network state before attempting network connectivity. This is not the new M activity.check self-permission. This is the check calling yourself permission method. You have to be careful using this because if you're using an IPC, if you're bound to another service, it will grant the permission on that as well. But in this example, we're just checking the network state to see if we have this permission. If we do, then we can go ahead and try to upload a crash. Now, if this permission isn't available in the application, then we have a graceful fallback. We'll just assume that it's true, and we'll try and let it time out. Like permissions, features are another powerful aspect of Android manifests. For example, you may want to use the camera, and you'll be tempted to declare that feature in the manifest. This requires Google Play not to list the app to any device that doesn't have a camera. So instead, I'd encourage you to list the features as optional and allow your app to detect and modify its behavior at runtime. Detecting the feature at runtime is very simple. You use the package manager, and you query to find out if the specific feature exists. Now your app can determine if it can enable it or not. Take an example of a social camera app. You may, on a tablet without a camera, you still may want the user to be able to browse photos and upload photos, but maybe they're not able to take them. So you would just at runtime detect this and disable the camera functionality. Important part of runtime detection is also being able to figure out that you're on a specific version of Android. So this is a very simple check. You check the builds. This has been covered, so I won't really dive into this much more, but when you're doing this with your SDK, you have to be very cognizant of the APIs that you're running on. Detecting some Android components may seem a bit more challenging. Speech detection, for example, is a service, and it doesn't rely on a specific Android version, but an installed service to handle this intent. And we can detect this in two ways. The first one, we can try starting the activity and then catching the exception if it's not found. But a little more graceful solution is to query the package manager for activities that can handle this action. And then if this list has any, then we know that there's something on the device that can handle this action. When providing your SDK to developers, it's tempting to want to use awesome new libraries like RxJava or Retrofit or OKHTTP, but you don't want to add a third-party dependency in all those cases. So you can use class path detection to figure out if that exists, and then you can use the provided scope in Gradle instead of the compiled scope so that your library can code against that. When we use Twitter API, when we use our authenticated Twitter client and hit the Twitter API, we use OKHTTP if it exists. But if it doesn't on the class path, then we fall back to the URL connection. This gives developers more power based on their own build script configuration. It's important that a developer that includes your SDK can use their standard testing tools. They don't want your SDK making network requests in their unit tests while they mock everything else. There's some tricks to make your SDKs testable, and by testable I mostly mean mockable in this case, since we're talking about public consumption. A mock class is just a dummy class that represents and has no ops for methods and calls and allows for various types of validation. By avoiding static methods, you may allow method calls to operate on a mock instance. If you're going to use static methods, make sure they can be tested in isolation and that the dependencies can be provided up front. Many mocking libraries have problems with final classes, Mockito for example, so avoid them if you can. Public fields also won't exist on your mock classes, so everything should run through a method for access. It's much easier to set up classes to test if your entry point uses interfaces. The interfaces allow developers to override the behavior, hit mock servers, or end memory stores instead of expensive or inconsistent real operations. Lastly, think about architecting your code in such a way that the tester would never have to mock more than one level deep. This encourages tests to actually be written and provides more stability. This class represents some traits that I think make it hard to test and mock. It's final and it's a singleton. It's pretty common in Java, although generally it's an anti-pattern. But it makes it very challenging to test in isolation. So what could we change to make this a little more testable? Instead, I recommend making this class an instance. The developer can reuse this and cache it when needed. Remove the final modifier on the class so it can Mockito or other frameworks can mock it, and allow the SDK to take its dependencies at construction time. Dependency injection isn't just a framework, it's a design pattern to help organize code around better testability. We've talked to you about some of the importance of ease of integrating an SDK into your existing app, extensibility, handling failure gracefully, runtime detection, and making your SDKs more testable. So let's move into the next important quality that we like to think about, and that's making things lightweight. Again, these lessons learned cover more than just SDKs and libraries. They're also applicable to apps as well. The important consideration for building a lightweight SDK are the binary size, watching out for the Dalvik method limit, limiting network usage, encouraging modularity, and optimizing startup time for us. Users are less likely to download big apps, and this means binary size really matters. Unlimited data plans are popular in some countries and unpopular in others, and many users around the world pay per kilobyte. Downloads cost them money, even if your app is free. And in many emerging markets, the cell connectivity is even too slow to download a large app. There's some great third-party libraries out there. They can contribute a lot to your application, but their impact isn't free. For Crashlytics, our crash reporting pipeline expects protobuf. And when we had implemented this, this was before the time of Wire or Nano or other lightweight protobuf libraries. So we use this so that we can serialize and compress the crash and send that up to our pipeline. The Java library for protobuf added over 700 kilobytes to our SDK, which is larger than the SDK is today. We didn't need all that functionality from the library, so we wrote a really lightweight crash protobuf file in parser and wrote it ourselves. The engineering time to reinvent the wheel for us was well worth it to keep the additional code much smaller. We kept it about 10K. We don't want this problem to happen to you as an SDK developer, so think about the size when you're putting it out there. There's an easy weight loss hack that I like. It focuses on data collection. If you just weigh yourself every day, you will lose weight over time. We take this approach to our SDK sizes. We actively monitor them on each build. We can weigh the true impact against developers' APK and graph over this time. There are no hard and fast rules around size increases or how a specific commit increased the size. We can just investigate it when it happens and know that if it was warranted or not. How many of you have run into the Dalvik method limit? In the world of Google Play services and RxJava and everything else, it's becoming a lot more common. There are solutions out there. Multidex is pretty common now, but it slows down your build significantly, and it's only suitable for modern Gradle builds. If you're using Maven or something else, it still can be problematic. For those of you who aren't familiar with this problem, it's a finite limit on the number of method invocations allowed to be referenced by a single DEX file. And it surfaces when the DEX tool tries to write all these references into a certain amount of memory space that's allocated, and it fails. The developer runs into this problem oftentimes before enabling multi-DEX and seeing their build drop from 6 seconds to a minute. Oh yeah, thanks. So instead of just enabling multi-DEX by default, oftentimes they will audit their third-party libraries and see what's being used and what's heavy and reconsider those options. So our goal and my advice to other SDK developers here is to limit your impact as much as possible and be extremely modular and lean. We use a great library in our build scripts that was written by an engineer at Quip, and it wraps some of the Android build tools to give a detailed data method count per package. This allows quick insight into the size of our SDKs and the size of our dependencies that are being used. Any network communication should be minimized as much as possible because of the impact on battery life, as well as for the data-conscious regions that I mentioned earlier. I mentioned earlier that Crashlytics uses protobuf. The reason for this is that they're exceptionally small. Unlike the schemaless definitions of XML and JSON, when you have to include the fields names on all communication, with protobuf, there's an IDL that both the sender and the receiver agree on that reduces the amount of information packed into the data. It's compiled into a binary format, and it's super compact when compared to JSON or XML. It's much faster to read as well, so serialization and deserialization is significantly improved. Our advice is that you should consider exactly what over-the-air calls you need to make and look for ways to make them as compact as possible. As I mentioned earlier, users may be paying for everything that you're transmitting. There's a new format that don't have in my slides here that I'd also recommend looking into. It's flat buffers. It came from the video game industry and was being used for texture rendering, and it's supposed to be exponentially faster than protobuf for serialization and deserialization as well, but it's a very similar format. Cell radio is one of the biggest sources of battery drain. So making sure that we're transmitting efficiently is key to avoid draining too much. A typical cell radio has 3 energy states: full power, low power, and standby. Every time you create a new network request, the radio transitions to a full power state, and it remains at the full power for the duration of your transfer, plus an additional 5 seconds, followed by a 12-second time at the low energy state. So a typical 3G device, every data transfer session will cause the radio to draw energy for almost 20 seconds. This means that 3 connections per minute will make the cell radio perpetually active. By batching those connections together, we can reduce that amount of time from almost a full minute to 20 seconds of enable time, giving about 40 seconds of idle time per minute. When we started Fabric, a huge concern for us was to provide the maximum amount of modularity so developers could pick and choose only the specific components out of our offerings that they needed in their application. We wanted to take advantage of the standard dependency management tools to provide this, so we used Maven's dependency resolution within Gradle. Even though we wanted modularity for our developers who needed the specific functionality, we wanted simplicity for developers that wanted to include entire sets and be up and running in no time. This diagram represents how we architected Fabric to support both of those goals that I just talked about. At the base level, we provide one artifact, which is the Fabric AAR itself. It's a transitive dependency for everything that we build. The Fabric artifact contains common code for everything that sits above it. These are things like interacting with the web dashboard, app onboarding, events management, caching, and more. The next level up, we group commonly shared code for specific sets of features. We want to provide this. This could be specific networking or authentication code, modifications of persistence, or anything else that is a lot more feature-focused. The feature level is user-focused features. It's sets of features that developers want to utilize, either as a group or individually. These generally represent the features the developer's choosing to pull an SDK in for. Think about things like crash reporting or analytics. Lastly, we have the interface level. This hits on that second goal that I mentioned. It wraps all of the dependencies that sit underneath it and allows for quick access for the developers that want the entire pillar. Now let's see how that works in implementation. The developer can put a dependency on the Twitter AAR, and they therefore get the functionality of Tweet UI, Tweet Composer, and Digits. Those are all separate pieces of functionality that we provide. But if they wanted to use those individually, they could just put a dependency on Tweet UI, for example, and have a much more limited amount of dependencies that they pull in. With Fabric, our goal was to quickly get set up and then sit quietly in the background, doing nothing unless needed, having a negligible impact on startup time of an app. There's a small amount of work that needs to happen synchronously to ensure things like exception handling for Crashlytics is set up correctly before we can handle crashes, but then other asynchronous initialization can be done on a separate thread. Because our SDK is initialized in the application or launch activity of the application, it's really important that anything that's done on the main thread will impact startup time. So SDK should start a separate thread or an async task as soon as possible to minimize the impact on startup. Even better if your SDK uses a thread executor to keep the number of threads running to a minimum. Although it's more complicated than an async task, you might want to consider to instead create your own thread factory class. If you do this, you should set the thread priority to background using the set thread priority and passing thread priority background. If you don't set the thread to a lower priority this way, it'll get the same priority as the UI thread, which can still cause jank. When we were developing Fabric and coming from our experience with Crashlytics, we put a huge focus on startup time. It's recommended that the developer initialize the SDK as early as possible so that we can catch startup crashes, but many developers were fearful this would slow down their application. So we addressed that through a few specific techniques. For all the SDKs being initialized with Fabric, we have a shared concurrency resources so we don't overwhelm the app with new threads. It's pretty important that we get out of the way as soon as possible. So all our SDKs are designed to delegate all heavyweight operations to the asynchronous initialization. The code path is returned immediately, so after the user synchronous initialization completes, we don't inhibit the startup time. The SDK is then in a prime state and can be used immediately, while some of the work will be queued until the async initialization is completed. We also don't want to load everything at app startup time. Some functionality, like embedded tweets, is only used at a later stage of the app. We want to load these into memory just when they're needed. We saw how binary size, being mindful of third-party libraries, watching out for the Dalvik method count limit, limiting network usage, and curtailing startup time can have a positive impact on your app or SDK, and it can be the reason that someone decides to use it or not use it. So we've created this powerful and lightweight SDK, but just like with an app, creating it is just the first stage. Following that, you need to get it into the hands of developers, get feedback, and iterate on it. There's a saying that I like: an API is like a baby. It's fun to make, but you have to support it for 18 years. An API you add will require support for future releases. Think about how it'll affect your roadmap, and think about your architecture choices. Both Java docs and README type examples are really important for developers to use your library. Document every public method, and document the expected use cases. Write minimalist sample code. It will be referenced for usage a lot more than your documentation, and people will copy and paste this everywhere. So keep it as concise as possible. If you're writing an image loading library, have your sample app be a very simple use of that. Don't write a full gallery app that someone will have to pick through and figure out just the specific parts of the image loading that they need. Lastly, think about deprecation. Inevitably, you release your version 1, and the internet hates you and your library. So you need to wipe away your tears, rewatch this presentation, and then start on your second version. Be nice to your developers. Instead of just removing a new method, mark it as deprecated and set a roadmap for removal and communicate that roadmap to the users of your SDK. Think really hard about introducing new public methods. You'll have to maintain them for a long time. When in doubt, leave it out and talk to your users about its actual need. Thanks for coming to hear about how the Fabric team creates lightweight and powerful SDKs. I hope you've learned a thing or two from my experiences, and I hope you can take advantage of these learnings in your own SDK or app and make them more efficient and easy to use. I'll be available for questions now. Yes?
So one of the problems that we normally face is like in an application, we have a dependency on a lot of things.
Yep.
And each of these SDKs, they have their own resources, like connect tools,
Yep.
and request queues. So is that something that you guys think about?
It is. Actually, on the Fabric Builder, we have some custom methods. Oh, sorry. He asked, a lot of SDKs have their own resources that they're using, either thread pool executors or other things. And is that something that we think about when building SDKs? And it definitely is. On our Fabric Builder, we have methods that you can set your own executor service. You can set your own handler. You can set callbacks. And that way we can use those shared resources among the SDKs if they exist. Yep. Yes?
Do you recommend using anti-threads like really long methods, for example, so avoid the method count, like how you guys had to do?
That has been a discussion point, and that is something that we generally shy away from. Generally, we like to think about using interfaces from the implementation for the public API, and then internally a lot of implementations. This is the same approach that the Google team has taken as well to a lot of their architecture. We want to balance maintainability and decoupled design and the solid principles with lowering the method limit and with multi-dex and other tools that are available. I would prefer to stay on the side of well-architected code at the cost of more methods, but it's something to be cognizant of regardless. Anyone else? Yes? Can you repeat that a little louder? Yep. So what we do right now is our plugin will take the AAR and unzip it and create a library project out of it, and we do that automatically. There is unofficial support for Gradle and Eclipse now through some projects. I don't know if that yet has AAR support, so that would be something to investigate. If your project is open source, then I would recommend that they check it out and use it as a library project. If it's not, then I would recommend looking at ways to give them a library project implementation of your AAR, which is just the compiled classes file and the resources. Yeah, so a library project is a folder that would contain the compiled source and the resources. And so you can create that out of the information that's gained in the AAR. So you could write a build script in Gradle, for example, that would unzip the AAR. It would create a folder. It would drop in the jar. It would create put in the manifest and put the resources in the style that's expected. And then you could deliver that to your Eclipse users. It's kind of hacky, but yeah. POI. Yep. We don't use very many Android classes at all. And there is an example with our executor service where we actually pulled in a version of the async task from a much later version of Android. And then we delegated new work on that so that it could support dependencies and priorities so that when we initialize lots of different things in our thread pool executor, we can know the priority of initialization. That is to kind of counter for that problem. But in general, we don't really use much of the standard Android stuff at all. Yep. Anyone else? All right, thanks for coming.